Now let's discuss what the magnitude of a vector is and its properties. So, to find for any vector u with xy as its coordinates, right, in a two-dimensional plane, r square, this just means it's a two-dimensional plane, we define the magnitude, norm, or the length of this vector u basically like this. Okay, now the terminal sides basically from the origin O. In this particular example over here, it says that the initial side of vector u is at the origin, and this is its terminal side p, right? And its coordinates are x and y, right? Now, to find the magnitude, first you must know the notation. So basically, the magnitude of u is denoted like this, or it can be denoted like this, or it can be basically just, yeah, these two ways are the denotions. Now, the vector u in this case can also be written down as OP because it goes from O till P. The O is the initial side and P is the terminal side. So obviously, the magnitude of u, if it can be written like this, it can also be written like this, right? Now, to find the value, you just used this formula. Basically, just square the x value and square the y value, add them up and take the under root. Really simple. Now, here's the thing. In this particular example, the initial side already exists at the origin. So that makes life a bit simple for us, right? But in cases where, for example, you do not have this vector over here, right? If it does not start on the origin, if it starts somewhere else, you'll have to find its relation, its coordinates from the origin, so that you can find its magnitude. Okay. Now, here's the thing. What really is the magnitude? Well, magnitude is basically the length of the vector without any directions, right? So it is a scalar quantity. So basically, obviously, over here, from this info, you cannot tell what the magnitude, the length of this vector is. It just tells you that it has an x value and a y value. So to find its length, you need to apply this formula. Simple. What are the properties? Well, if the magnitude, let v be a vector in the plane, and let c be a real number, so a scalar, right? It says here that the magnitude is greater than or equal to 0, and magnitude is equal to 0 if and only if the vector v is equal to 0, right? Now, basically, the magnitude is 0 if the vector is a null vector, right? That's just self-explanatory, because if it is a null vector, a null vector has 0 length. It is nowhere. It's just 0. It's nothing. So obviously, the magnitude will also be 0. And here's the second property. If you take a scalar c and multiply it with the vector v and take its magnitude after that, it's basically just equal to the magnitude of c multiplied with the magnitude of the vector v. You can apply both of these are interchangeable, right? So yeah, that's about it.